In this video, I will give you a formal definition of a derivative of a function. Suppose we are given a random function y equals f of x. So, what is the slope of that random curve? How to find it? Derivative actually gives you the instantaneous rate of change at any point on your curve. The idea of the derivative comes from the idea of the slope or gradient of a straight line. Now, what is the slope or gradient of a straight line? It's just vertical change over horizontal change, or rise over run. In other words, change in y over change in x, so as known as delta y over delta x. And slope actually shows you how steep is your straight line is, so the steepness of a straight line. In order to find the slope of a straight line, you need to pick any 2 points on a straight line. Doesn't matter which ones, since slope is gonna be the same. So it's a constant, it doesn't change. So basically slope and the gradient, they are precisely the same. The derivative of a curve is a new function that gives you the slope of a line tangent to the curve at any point. Recall that the tangent line is a straight line that touches your curve at one point exactly, at one point of contact. It skims the surface, grazes the curve and touches it at one point. Now let's move on. How to practically find the slope of a curve at the given point, let's say x. Actually, if we know only one point, however, we need to know 2 points in order to be able to find the slope. Let's start by considering another straight line, a second line, a green line on the picture, that passes through this point x and through another point, let's say some delta x distance away. Let's call it x plus delta x. Now, since we know 2 points on the green line, we can compute the slope of a second line by using this rise over run. All we want to do is just find the difference between y's over the difference between x's. So we need to find the corresponding y values. So for the point x, the corresponding y is gonna be f of x. So we have x and f of x. Now for x plus delta x, the corresponding value is gonna be not f of x, but f of x plus delta x. So that's our 2 points. So let's find the slope between them. Now, all you want to do, first of all, find the difference between y's. So your y2 is gonna be, so your x is x1, your f of x is y1, so your x plus delta x is x2, and your y2 is f of x plus delta x. Now, instead of y2, we are going to write f of x plus delta x minus y1, which is f of x. This is your top. And your bottom becomes x2 minus x1. So x plus delta x minus x. So you want to cancel these x's, and you are gonna left with delta x on bottom. So this formula is known as difference of quotient formula. Okay, what we did, we found the slope of the second line. But remember, actually we are looking for the slope of the tangent line. So in order to get this, we can take the limit of this difference of quotients when this distance delta x goes to 0. We can get this value by moving this second line closer to the green, to the tangent line. So in a nutshell, the derivative of a curve at the given point is a slope or gradient of the tangent line at this point. So the slope of the curve at the point A is the same as the slope of the tangent to the curve at this point A. So the slope is also the rate at which y increases with respect to x. So the derivative of a given function is a new function that gives you the slope of the line tangent to a curve at any point. So derivative of gradient function or derived function of a function is the slope, gradient or steepness or rise over run of the line tangent to the curve at any point. Okay, so it gives you also a rate of change at any instant, the instantaneous rate of change at any point. Now, the differentiation is the process of finding a general expression for a gradient of a curve at any point, at any instant. Now, let's talk about terminology and notations at this point. So, complete symbol dy dx, or spoken dy by dx, or just dy dx. The derivative with respect to x also could be written in terms of apostrophe. So, f prime of x, the way we would say, or sometimes it says f dashed of x. So these two notations, they mean precisely the same thing, the derivative of a function y equals f of x. So we can use them alternatively. And finally, oh Lord, we have arrived at formal algebraic definition of the derivative. So dy dx or f prime of x equals limit when delta x approaches 0, f of x plus delta x minus f of x over delta x. So again, dy dx or f prime of x stands for the derivative. Alright, let's move on. There is the problem. Find the derivative using the definition of the derivative or by the limit process for the following function. F of x equals 3x squared plus 12. Some more problems to carry out.